Here's a good Poisson problem from 2014, paper 2, section B. Again, this is calculator friendly. And yeah, with your calculator, it's going to make this problem pretty easy. You just got to remember how Poisson works. You're given the mean, so the mean is 0.6. This is the number, so the average number of complaints received per day by customer service is 0.6. First question, on a randomly chosen day, find the probability there are no complaints. So our x value, which we're trying to achieve, is 0. Well, this is an exact number, so this is a Poisson PDF. And when you go to that on your calculator, you're prompted for the mean, which is 0.6, and you're also prompted for your x value. So this is really straightforward. Poisson PDF of 0.6 comma 0. And you punch that in, you'll get 0.549. So the probability there are no complaints on a given day is 0.549. Now part 2 is a little trickier, that there are at least 3 complaints. That means 3 or more. And we don't know where it ends. So what we want, since you're looking for a range of complaints, 3 or more, that's a CDF, cumulative distribution function. So we want to take 1, which would be all the probability, and subtract up to 2. So it's 0.6 again for the mean, and 2. That way, if you take 1 and subtract out 0, 1, or 2 complaints, that's going to give you 3 or more. So you just punch that in, and you get 0.0231. Part B, in a randomly chosen 5-day week, what's the probability that there are no complaints? So we want day 1, no complaints, day 2, no complaints, day 3, 4, and 5, likewise, no complaints. So we're trying to get none, and none, and none. You get the idea. And none, and none. And in probability. And if you can phrase a statement in the and form, that means to multiply. So day 1, no complaints would be 0.549. Day 2, 0.549. Day 3, same. So what you can just do is take 0.549 and multiply it together 5 times, or just raise it to the 5th power. And that'll give you the answer, 0.0498. On a randomly chosen day, find the most likely number of complaints received. Well, we know, I mean, this is just common sense. You know that the probability of getting 0 complaints is 0.549. Now, if 0.549, if that's your probability, that's over half, which means that 0 complaints is the most likely number because it's over half the probability. So again, we could put that into words. So since P of 0 equals 0.549, which is greater than 1/2, then the most likely number of complaints is 0. Most likely number of complaints is 0. And while I'm thinking about it, critiquing my own handwriting, when you do your papers, be sure you write legibly, please. I'm just writing fast here, because if the reader can't read your answer, guess what? They're not going to give you any marks. All right, let's move on to the next. I think there's one more section to this. So this is the last section of this Poisson problem. A little bit different. It says the department store, new policy, the number of complaints received per day now follows Poisson with a mean lambda. So they don't tell you what the mean is. On a randomly chosen day, the probability there are no complaints is now 0.8. It was 0.549, so I guess the policy is working. All right, so the object here is to find lambda. So if you would just write out, we know that the probability that x equals 0 complaints, write out the formula, is the mean to the x power, e to the negative mean. I'm just using lambda because that's what they said. I think your formula packet might use m, I'm not sure, over x factorial. And we know that that's equal to 0.8. So we know the probability of 0 complaints is now 0.8. So we have to take this thing and solve for lambda. Well, x represents the number that we're trying to achieve, which is 0 in this case. So let me replace. So we have lambda to the 0 power, e to the negative lambda over x, which is 0 factorial. And we know that's equal to 0.8. So all we have to do is solve this little equation. Well, all the zeros don't pose much problem. So lambda to the 0 is 1. So we have e to the negative lambda, and 0 factorial is 1 on the bottom, equals 8/10. I'm just going to go ahead and write that as a fraction, because I see I have a negative power, so I'm going to flip that over. In other words, I'm going to reciprocate both sides. So e to the lambda is equal to 10/8. And we can just use logs to solve that. Take the natural log of both sides. So ln of e to the lambda equals ln of 10/8. Yeah, buddy. Lambda comes down. ln e is 1. So lambda equals the natural log of 10/8. Go to your calculator, punch that in, and you've got the answer. And I got, let's see, I got 0.223. So that is now the new mean. The average number of complaints per day is 0.223. And that's the end of number 11, dealing with Poisson.